Okay guys, hello. So in this tutorial we're gonna start tracing the sub-catchment that we've done before in the AutoCAD. So first open up the application SWMM 5.1, then you select project. First you go to the defaults, and basically we want to set a default setting. We want to change the default setting for our convenience. In this example, I show you the we put the ID prefix for every type of object in SWM 5.1. So you have rain gauges R, sub-catchments S, junction J, outfall O. So anything that we added for each object, they will have a prefix. So if it is the first sub-catchment, so you will have a annotation of S1 followed by S2, S3 and so on. And for a node or for conduit, we will have a C1 starting from C1 and up in incremental value. So it is important so that we can easily recognize which is which one is junction, which one is node, which one is outfall. And also on the second tab, which is the sub-catchment tab. Sub-catchment tab, you can set the default value for every sub-catchment you put in the study area map, which is the windows behind the project default window. So you can set the area, you can change the value of area, the width, the slope, impervious, percentage of impervious. This depends on your value, your project type. You can refer to your MASMA guidelines. So you need to change this accordingly based on your MASMA. Then you click OK, and also you need to change in the lower ribbon. Click on the arrow of flow units, change it from cubic feet square to cubic meter square. So we do a second check. You can see the value of slope has been changed. All the value is changed. All the values have changed to CMS, cubic meter square. So first off, you need to upload your figure that you have plotted from AutoCAD. So you click the view and then select backdrop and load. So in the backdrop image file, so click, find your figure, the JPEG file, which is in this case is IDP layout 1.jpg. Click OK, it will be uploaded. As you can see in this example, it's very blurry due to the high resolution that I've plotted before. So I advise you to plot the drawing of AutoCAD into smaller resolution. Select a smaller resolution rather than 1600 times 1000 over. So you select a smaller section, a smaller value of smaller size of canvas. First, you put a rain gauge there. Select rain gauges from the left windows and click plus and place your rain gauges. You can place anywhere within the sub-catchment. Below this rain gauges is a sub-catchment option. So you click the option. So you can click plus, the green plus icon. So you can start tracing each point. They give a nice presentation in the report. So you trace on every edges, and then just on the final line you can right click it, so you can form a closed loop. So you can close the sub-catchment area into a polygon, and you repeat the process on each sub-catchment in the development project. Next, we go to hydraulics option, and you click hydraulics and you select nodes. So under nodes we have junctions, outfall. So we select junctions, which is basically sum. You just retrace your sum based on the planned location. So as before, the location is very simple. It's simplistic. So I advise you to go more detail on the location of sum. So after that, you can connect the sum, the junctions, by clicking links and select conduits. Basically, conduits is either a open drain or a rectangle, round circle pipe, reinforced concrete pipe. So you can select, and then to help you with the to recognize each and every object in this study area map, so you can click Windows, you click Tools, Map Display option, and then you click Annotation. So you basically tick every display so that it can show name for every object. So you can see there S1, S2, S3, S4 for sub-catchment, and then C1, C2, C3, C4 for conduit, and so next we go to hydrology, and we want to edit the sub-catchment attributes. So in the sub-catchment 1, you click sub-catchment 1 and click the hand holding a pen there icon, so you can edit the attribute. Select rain gauge. You want to change the rain gauge reference and the outlet. So in this catchment 1, the rain gauge will be R1 and outlet is J1, junction 1. So you can see a dotted line will be connecting the sub-catchment to the junction. And also you want to change the area of the sub-catchment, as we have calculated before using AutoCAD AutoLabs. So the value is in hectare. So the value that you have, the value that you obtained before is in millimeter square. So you convert the value into hectare. So here the value is equal to 0.695 hectare. And then you do the same for each sub-catchment and assign the value of area respectively according to the previously calculated value. You can also directly click the S3 and S4 and S5 to edit the value without closing the window of attribute. So it will be easier and faster to do that rather than closing and opening up again for each and every sub-catchment. So once you finish that, you need to change the attribute for junctions. So in each junction, what is important is that the value of invert level, invert EI. So you need to change it based on the invert level of your drain. So you need to know the proposed ground level. So the maximum height of drain that you are proposing, let's say in this case you have existing ground level of 46, and your maximum depth of a drainage is 1 meter. So there you have your invert level is 46 minus 1 is 45. So the rest need to be changed according to your plan. So in this example, the junction is not connected to the main drain, but later on in your own work, you need to connect it with the main drain so that the runoff can be channeled to the proper area to avoid flooding. So the next part is you need to change the conduit attribute. Conduits basically refer to your drainage, open drain. So you can set it the same as before. Is you select required conduits and then click on the icon of hand holding pen. You can edit it. So by default, the shape of the conduit is circular. So you can change it into a rectangular, and is example. So the maximum height is 0.9 and bottom width is 0.6. So the sizes is the sizes depends on the current available sizes on the market. So you need to have that reference. Change into the appropriate sizes and do the same to all conduit. Next thing is to assign the rain intensity. In this example, so you need to select the time series from the left window, and then you click plus icon, and then you put the name there, time series name, and then basically you just distribute the value into, in this example I distribute it into each every 15 minutes. So the value of rainfall intensity in this example is 0.1 millimeter per hour. So I signed for 2 hours. So the peak value, which is 0.1 millimeter, will be at time of 1 hour. So key in the value 0.25. The example want to do 0.1 average 1 hour rainfall intensity. So you click OK. Once you finish doing that, then we try to run the simulation, but it was unsuccessful. And then the pop-up window will show you the problem that causing the unsuccessful simulation, which is the rain gauge issues. Rain gauge is not assigned to time series, so you need to select rain gauge in hydrology, rain gauges, and then edit the rain gauges attribute. So under time series, you can select Padang Besar, which is the name of the time series. Try to do the simulation, was unsuccessful due to the interval time is not synchronized with the time series. So you need to change the time interval for the rain gauge into 15 minutes, as we have assigned 15 minutes there. So you can run the simulation. It was successful. Click the icon, like a drainage icon there, and then a pop-up window will appear, profile plot section. You key in the J1 and J5, which is basically the joint available in this project. You want the J5, and the program will analyze the conduit connecting between J1 to J5, and you click OK. So profile node J1 to J5 windows will appear. Then you can click map on the left window, then click play. The program start the simulation to show you the depth of the drainage along the conduit between J1 to J5 until the time series is finished. So basically this is the end of simulation. You can check the maximum depth. You go to the report and click summary. Then you can check the sub-catchment depth, node depth, and then sub-catchment runoff, node depth. You can determine the maximum depth, whether there is a flooding in the node, or if there is any flooding, so you need to change the maximum height of your drainage. So in this case the rain is very low, so there is no flooding in this example. Okay guys, I hope you can successfully simulate the rain, the analysis on your project based on your design. Make sure it is detailed design and then detailed analysis. You can print out, attach the report of the summary in your report for road and drainage, so it will be well presentable. And good luck.